Using yeast in any food product can be a confusing endeavor. After all, it is a living being that needs to breathe, eat, and drink just like the rest of us. The different types of yeast can be even more confusing, with different species being used to bake bread compared to bake a cake, and yeast to brew lager compared to brew an IPA. To understand more about how Brooklyn Brewery uses its yeast to create their beer, we first did research on exactly what yeast is. Brewer's yeast, or Saccharomyces cerevisiae, is a single-celled organism that is typically used in multiple different baking, cooking, and brewing processes. Besides the long scientific name that I really hope I didn't butcher, yeast is similar to most life you know on Earth. All yeast must eat in order to survive and grow, and it is the same for yeast during the brewing process. The yeast that we will be focusing on is brewer's yeast, which is not even a specific species of yeast. It is more a category to put the yeast that is commonly used in brewing in. Brewer's yeast contains two different kinds of yeast. The first of the two is top fermenting yeast, or ale yeast. These yeasts are used most commonly in the process of brewing ales, and as the name entails, does its job at the top of the fermentation tun. The yeast will eat the sugar that is located in the wort and produces alcohol and carbon dioxide. The brewer would then filter the yeast out from the top of the tun and transfer it to a new batch of wort for use. This process helps to mitigate the cost of buying new yeast, but it does have its flaws. Yeast, like all living things, has the possibility to have randomized mutations in reproduction. These mutations eventually become evolutions, causing whole generations to have certain new traits and characteristics. The problem with these random mutations is that some mutations can cause the beer to adapt an unpleasant taste. This means that brewers must purchase a new generation of top fermentation yeast in order to keep the gene pool large and minimize the amount of beer-ruining mutations. No incest.
Only incest.
Bottom fermentation is when yeast undergoes the fermentation process at a slower rate at the bottom of the fermentation tun. Bottom fermenting yeast works best at colder temperatures, about 5 degrees Celsius to 10 degrees Celsius, and therefore eats and produces alcohol and carbon dioxide at a much slower rate than top fermenting yeast. Bottom fermentation was believed to have first been used in Bavaria in 1420. According to the Oxford Companion to Beer definition of bottom fermentation, before 1420, the typical way to use yeast in beer was top fermentation, which used yeast that worked best at 17 degrees Celsius to 25 degrees Celsius. The brewers in Bavaria found it easiest to use yeast that worked better in colder temperatures so that they can brew beer in the cold caves of the Bavarian Alps. One major flaw of bottom fermentation yeast is that you cannot reuse the yeast in a separate batch of wort. The yeast is thrown away, and the brewer must purchase a new generation for their beer. Depending on the beer, you can leave the yeast in for longer to get a more alcoholic beer, or leave it lighter. There are multiple things that can be done with the carbon dioxide that is produced by the yeast. The carbon dioxide can be filtered out and not used, or it can be used in a process called natural carbonization. One key part of the brewing process is the carbonization. Without some carbon dioxide, the beer that you drink will be completely flat and not have the good taste that we want in our beers. There are two main ways to carbonate the beer, and that is natural carbonization and manual carbonization. Manual carbonization is standard, where a machine puts carbon dioxide into the flat beer. Natural carbonization is when you leave the yeast in the beer and add extra sugar so that the yeast can keep eating, causing the beer to become naturally carbonated. Natural carbonization is much more sustainable than manual carbonization, as you do not have to purchase a carbonization machine. Natural carbonization always results in a more alcoholic beer, as the yeast will never stop producing alcohol with carbon dioxide. Another large part of the fermentation process is aging beer. The aging of beer is similar to the aging of alcohol such as wine, but instead of being aged for centuries, the beer is only aged for weeks or months, as the yeast can go bad and ruin the drink. When beer is aged, it becomes more alcoholic and more carbonated, but there are also other factors that a brewer can add in order to make a better tasting beer. If beer is aged in barrels, the brewer may age the beer in a barrel that had once held another alcohol, that can fuse the flavors of the two drinks. If you age a beer in a barrel that once aged wine, the beer can adapt that wine's taste characteristics and create a much more unique drink. This also applies to drinks like rum and whiskey. According to Scott Simpson, Brooklyn Brewery's head lab technician, Brooklyn Brewery gets its yeast supply from a well-known yeast lab on the East Coast. The lab is called White Labs. The yeast that they purchased from White Labs is actually White Labs' best-selling product, and that is WLP00. WLP00 is a brewer's yeast that is in the American style. It is hardy and resilient and does well in most brewing climates.
WLP00, America's yeast.
Once the yeast is shipped to Brooklyn, one strain can typically be used in around 6 different batches of wort before any noticeable defects are discovered.
Alright, so I'm going to talk about the malting process. If you didn't know, my name is Joey. So Oliver already talked about this a little bit, but when you start the malting process, you gotta soak the grains in water a little bit so that they kind of think they're growing. Because when you want it, so there's 3 main ingredients in the barley. There's the starches, the enzymes, and then like the plant itself. And you only want the starches and the enzymes because the starches become the fuel for the fermenting process that Che just discussed. But in order to get the starches into a state that the yeast can ferment them, you got to break them down into more simple sugars. So the plant actually also has to do this, so it has enzymes kind of built in that help break down the starches. But they're not in it when you first get the barley, so you got to let the plant grow a tiny bit, and then the little enzymes will start to like develop within the barley seed, and then you kill them in a process called malting, which Oliver already talked about. So when you malt them, you put the barley into like a giant kiln, and then you kill the plants, but you still have the enzymes and the starches, and that's what you need. So most barley is very lightly malted, and this is because if you malt it too much, you'll lock up the starches so that they actually can't be broken down by the enzymes, and that's bad because then the beer is less alcoholic. But most beers have this much lighter roasted malt, and then they add in maybe a little bit of the darker malt so that it has more body. So the heavier malt makes more body, lighter malt is more alcoholic. The yeast IPA that we're talking about uses a crystal malt, which is a very traditional type of malt, the kind they used in because the yeast IPA is supposed to represent the British IPA, the original one, so it's a very traditional British type of malt that's a little bit dark. So then you take this malt and you have to put it, so then during the tour, the first room had a bunch of giant machines that we all looked at, and then the other room had the giant fermentation machines that Che talked about. But the first room has like the first 4 machines, and those are the mash tun, the lauter tun, the brew kettle, and the whirlpool. So the first one is the mash tun, and then what you do is you take the malt and you have to mill it first, and that's just cracking the shell open so that when you put it in the mash tun, you gotta soak it in water, and the water has to be able to enter the shell, so you gotta mill it first, and that's called grist. Then you put the grist, you put in the mash tun, and you soak it in boiling water, and the boiling water will activate the enzyme so it starts breaking down the starches into more simple sugars. So most beers, the mash water is about 150 degrees, and then there's actually 2 different types of enzymes, alpha and beta. Alpha enzymes get activated at a little bit lower than 150, and beta at a little bit higher. So alpha enzymes break down the sugars a little bit more, or the starches a little bit more into finer sugars, so that it actually results in more alcohol. And beta enzymes, or beta amylase enzymes and alpha amylase, they make it into more heavy beer, or more bodied beer but less alcohol. So the yeast IPA is brewed at around 153 degrees, which means there's more beta amylase enzymes being activated, which means that it's a bit of a heavier beer and a darker beer. So after that, all the mash juice and stuff is put into the lauter tun, which is this other giant machine, and they spray down the mash with like hot water to make all the sugary water run off into the next machine, and this is called sparging when they spray it down. So the lauter tun is basically just a big filter. In the olden days, the mash tun and the lauter tun would actually be the same machine, and they'd be mashing all of the barley, all of the grist, while letting the wort, which is the sugary water, letting the wort run off. But it's a lot easier if you have 2 machines, but then obviously you have 2 machines and it's more expensive and less space efficient, but it requires a lot less skill. all machines do the whole thing. There's just like a little monitor booth for whoever's overseeing it. So louder tun, then it goes into the brew kettle. And this is where the wort is brewed and also where you add hops. So this is the hops that Sebastian was talking about. You can add hops at like any point during the brew process, during the brew kettle section. If you add hops and you want to have like a aroma of hoppy aroma, then you got to add it. It's better not to use the brew kettle because the brew kettle will boil away all of the like aromatic oils that give it a smell, which is okay for the yeast IPA because it's not supposed to have a hoppy aroma. But some beers do need that, and then they use like a machine called a hop back, which recycles the aromatic oils back into the wort afterwards, after exposing it to the hops, so that it retains the smell. After the brew kettle, it all gets funneled into the whirlpool machine, and that's just another strainer to get rid of the little bits of malt that are left in the wort and the little bits of hop, because hop is like this little plant fruit almost, so they gotta filter out everything that gets left in the wort. This whole process takes around 4 to 6.5 hours, and they can do about 25 barrels at a time, which is a lot. That's a lot of beer. So after that, that's the final step in the malting process, and then it goes into the fermentation process, which Che already talked about. And those machines can handle like up to 200 barrels is the largest one, and it's like they have